Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Muhammad Nazul Effendi Bermaidrus. I am from Polytechnic Mersing. Today I would like to present about my research study which investigate the performance of line following robot with different IR sensor position mounted. Line following is one of the methods used in mobile robotics to navigate to other places. Commonly, infrared sensors were used to send the line with its backlight on white surface. Line following robot having the ability to detect and follow particular line to complete the task purpose autonomously. Previous study shows that the line following robot can be applied in various applications such as delivery, industrial, transportation, car parking, educational, and competition. Many studies were conducted on developed line following robot and improve the performance of line following navigation. In order to move forward, turn left and to right, the line following robot was designed with different type of wheelbase. For example, two main wheel connected with gear motor combined with free wheel you used to navigate on line following. Then four-wheel autonomous control of line following robot were used for the line following competition. Then two main wheel combined with two free wheel were used on the restaurant serving robot. Therefore, the different number of wheels used in line following navigation depends on its task application. There are two common methods were used to detect line, namely optical based and vision based approach. Infrared sensor or light dependent resistor were mostly commonly used for the line following robot navigation. The previous result shows that the mobile robot was successfully able to navigate using a vision method through the provided path. However, this method requires an advanced algorithm and high-speed processor. Generally, more than 3 photoreflectors were used to detect line following, tracked by capturing the line position with optical sensor mounted. However, there are certain studies used to number of infrared sensors to detect line following, and X sensor to detect line following were used. Therefore, a different number of sensors can be used to navigate on the line following path. Next, there are also studies develop different algorithms in line following detection. For example, by using three variables which are proportional, integral, and derivative that give feedback continuously, looping control system which help keeps the robot on track. Then the fuzzy logic was implemented, shows high accuracy capability to detect different line colors which represent different routes. Therefore, the study indicate that different types of algorithm can be used on the line detection navigation. There are also study on alignment of sensor position. For example, line sensor configuration method to place sensor for junction tracking and junction turning were proposed successfully to navigate. Then double line sensor position, which in front and back located on robot body, was successfully developed on of a restaurant serving robot. In addition, a robot with 3 label alignment of infrared sensor on the bottom to detect the line was successfully designed. This indicates that the different alignment of following sensor can be used to detect line following. However, there is no specific study was conducted to investigate the effect different location of line following sensor on the performance of line following robot. Therefore, this study aims to measure the performance of line following robot with 6 location position mounted from the center of main wheel. Methodology for this research, there are two types of track, which is rectangle and circle track as shown in figure 1. The line following robot will start navigate before the counter sensor and complete the cycle after pass again the counter sensor to obtain interval time for complete cycle. During the study, 30 attempt for 6 position mounted of line sensor has been recorded as shown in figure 2. The nearest distance is 0 cm, where it is on the center of wheel, increasing 5 cm each location until the far location is 25 cm. Therefore, 360 number of samples has been recorded during the study. Maximum, minimum, mean, and distance standard deviation has been recorded during the study. Table 1 shows the simple algorithm Simple following algorithm used in line following robot. There are 5 conditions, which is condition 1, when center eye sensor detect low, robot will move forward. When center IR and left one IR sensor detect low, robot will move left. When L1 and L2 IR sensor detect low, robot will move left. The condition 4 and 5 were the opposite response of condition 2 and 3. Next is the result performance of rectangle track. Figure 3 shows the line following track of rectangle track. The data with 20 seconds and above indicate that the robot failed to complete the round. Location 1 tends to reach a best performance with 7.7 seconds of minimum time interval. However, there were 4 attempts failed. The second best performance obtained when the line following sensor is located at location 2 with 10.10 seconds of minimum time interval. Meanwhile, location 3 tend to obtain 11.6 seconds. However, location 1 failed to complete any testing, indicate that location 1 is not in appropriate position following sensor because the sensor is located parallel with the center of field. Figure 4 shows the performance on the circle track. Location 1 tends to achieve a best performance with 11.27 seconds. Location 5 tends to reach a second best performance with 12.11 seconds. Robot succeed to complete every 30 attempts compared with the same location in rectangle track. The result indicate that location 1 is not a suitable use on rectangle line following track. The third best performance is obtained when the line following sensor located at location 4 obtained with 12.60 seconds. However, location 1 failed to complete any complete cycle, indicate that location 1 is not an appropriate position for circle and rectangle track. Next is a summary for the result. The result shows that location 2, location 3, location 4 and location 5 tend to achieve a good result with standard deviation respectively. The result indicate that location 2, location 3, location 4, location 5 are reliable location on line following sensor can be mounted because all of 3 number of testing for rectangle and circle track were successfully and completed without fail. Then location 2 can be declared as the best location with 10.43 rectangle track. After that, location 1 can be declared as the best location with 11.84 circle track. L1 shows the best location for line sensor on circle track but not in rectangle track, cannot be declared as the best location for both tracks. Therefore, location 3 can be declared as the best position for both track with second and first best position for rectangle and circle track. However, the result location location 1 where the line following sensor located on the center of the wheel shows that every attempt rectangle and circle will fail. This indicates that the location is not an appropriate location for the line following sensor to navigate. In addition, location 1 shows 4.13 of standard deviation because there are 4 attempts from 30 attempts robot failed to complete the task for rectangle circuit. This indicates that L1 is not a stable location for certain line following track. As a conclusion, the study investigated the performance of line following robot with the different infrared position sensor mounted on rectangle and circle line following track. Results indicate that location 2 and location 1 were the best location mounted for rectangle and circle track respectively. The finding shows that location 3 can be declared as the best position with 12.10 seconds and 13.60 seconds of the average time for rectangle and circle track. Therefore, an appropriate line following sensor is important to ensure an optimum performance of line following robot to navigate. Nevertheless, different algorithm line following detection method may be investigated to improve the following robot navigation. Endorsement, we would also like to acknowledge the Mersing Polytechnic for providing facility for the study. Okay, that's all. Thank you.